Hello everyone. Today we will be looking at how we generate the wavelet and scaling function for the Haar filter bank. As we can recall from lecture 9th that the scaling function phi of t is given by summation n going from minus infinity to infinity h of n phi of 2t minus n, where h of n denotes the low pass filter response. Similarly, the wavelet function is given by summation g of n phi of 2t minus n, where g of n denotes the high pass filter response. N goes from minus infinity to infinity. So, today in this demo session we will see how we generate the scaling and wavelet function using these expressions. Again, recalling from the lecture, for the Haar filter bank case, we have h of n given by a 2-length sequence, which is one and 1 at 0th and first sample, and the gn sequence is given by 1 and minus 1. We use this and we will try to generate the scaling and wavelet function. Our h of t, if we try to draw, it has two impulses at 0 and at 1. If we try to draw h of 2t, it will look like this. There will be two impulses, one at 0 and one at half, and h of 4t similarly will look like this, and h of 8t will look like this. And similarly we can keep drawing more dilates for h of t. Now we have h of 2t convolved with h of 4t, which is a sequence which looks like this. It is a 4-length sequence, and now we try to convolve this with h of 8t. And this will look like a train of impulses. There are 8 impulses in this, going from 0 So, as you can see, the support for this is from 0 to 1 even now, and I mean in every case, but the impulses are becoming denser and denser, they are becoming closer, and if we keep continuing in this way, we get a signal which looks like this. And this is exactly what we called as our scaling function, which is phi of t. Next, we will move on to how we generate the wavelet function. So, we have the wavelet function given by this expression h of t, n going from minus infinity to infinity, g of n phi of 2t minus n, and phi of t we can find from phi of 2t minus phi of 2t minus 1. Let us try to draw these two signals. these will give us, oh sorry, so this will give us a function which will look like this. And this is our wavelet function which we called phi of t. Now we will have a look at some simulation demos and to see how we can use more dilates of phi of t to get a better approximation for phi of t and how it converges to an exact brick wall sequence. So as we can see here, there are two impulses, one at 0 and one at half, and once we convolve this with phi of 4t, we get 4 impulses, one at 0, half, and 1 by 4 and 3 by 4, as I have just explained. So going this way, what we get is a better approximation for phi of t. And the simulation below shows how we get wavelet function. So wavelet function essentially looks like this, and once we keep adding more and more dilates of phi of t, and we get a better approximation for it. So this is how we construct the wavelet and scaling function for the Haar filter bank. Thank you.